So now we are going to use the third method, all right, that involves the Pythagoras theorem, okay, to find out the perpendicular distance between a point to a line. All right, so of course, the final answer, the final formula that we apply is this one. Okay, so according to the steps, there are 3 steps only. So if you want to use this method also can, just that again, you need to memorize all the formula and steps by your own. Okay, right, so how we get the formula here? Okay, so CD is equals to square root AC square minus AD square. So generally this formula is Pythagoras theorem, which means you want to find out the length for CD, right? So it is a right angle triangle, therefore you should take AC square minus AD square and then you take the square root. Alright, so then you can find the CD. Okay, but of course when you look at it, it looks like very ideal. Okay, very easy to apply, but to be honest, you actually don't know the D. Okay, so you actually don't know the D at first. So how can you find out the AD here and also the length for AD? All right, so that's why you need to come up with some uh, prior steps before you can apply this formula. Right, so I will just roughly show you how the formula comes from, okay, and how the steps come from. Okay, so we are having theta here, still the same like what I showed you just now. So maybe I can draw this right angle triangle so that you can see it clearer. All right, so I'm having D, then this is C, this is A, and this is B. So you actually want to find out the CD again, the length of CD. Okay. All right, so for this formula, generally there are a few formula that you need to know first before you want to get the final steps. All right, so first of all, you need to know by looking at the triangle here. Okay, so you should know that I want to involve, because in our formula we are having AD, right? So if according to this triangle, I might want to use the formula cos theta is equals to modulus AD divided by modulus AC, which means adjacent over hypotenuse. Right, so this is the formula that we are going to apply. And after that, because of we are having a cos theta here, therefore we might want to use the angle between two vectors formula that involve cos theta. So I'm going to use AC and also AD again. All right, so I'm going to use AC and AD again, and then I want to find out the, I want to write out the formula. All right, so for this formula, generally it will be AC dot AB equals to modulus AC modulus AB and then cos theta. So maybe some of you will ask that why for this formula I don't use AC and AD. The problem is because of I don't know the AD actually, so I cannot apply it. Okay, so for this one, for the AD part, I actually want to apply it later on. Right. Okay, so this is what I have for now. Okay, then after that, from here, right, my aim is to find out AD first. Okay, so I will want to find out AD first. So according to the formula that I show you, what is AD? So AD is actually equals to AC cos theta. So I'm having AC and then cos theta. All right, then if I continue, what is AC cos theta? Because you actually don't know the cos theta, right? So you need to substitute it by using some other things. So according to this second formula that I write out just now, you will see that AC cos theta is actually equals to AC dot AB divided by AB modulus. Okay, all right. Then this is how you get the AD. Generally, you can get the AD already one, but in our formula here, you see that AD is equals to AC multiplied with AB cap. So what is AB cap? So AB cap is actually the unit vector. So this one is actually the unit vector of AB. So they just rewrite it again. So how I know that it is a unit vector of AB? Because you know that AB vector divided by the modulus of AB, you'll get the unit vector of AB. So you will have AC dot AB modulus. Oh, sorry, AB cap, which is the unit vector of AB lah. Right. So once you know the AD already, then now you can straight away apply the formula to get a CD. So to get a CD, the formula that you apply is AC modulus square minus AD modulus square. Okay, so the AC modulus square, right? The AC you can straight away find out the vector, okay, in a very easy way, okay, because you already have both coordinates. So for AD, it's very troublesome because of you don't have the coordinate of D. Therefore, you need the help from other formula so that you can combine them and find out the AD that you have. All right, so this is what we have for method number 3. Okay, Pythagoras theorem. So again, in the exam or maybe in the formula booklet, they won't show you all these details, right? So if you want to apply this method, just make sure that you have to remember the proper steps, okay, and also the proper formula. All right. Okay, so again, I will discuss this method by using one example, right? Example 20. So if you're interested for example 21 again, then you just try out on your own. Alright, so I will just delete this first. This is the method number 2 that we discussed in the previous video. Okay, so again, if you look at the question one more time, you realize that okay, everything is still the same. So usually for me, if I want to make it in a simple way, I will just draw a triangle here. Okay. Alright, so according to our steps, this is A, this is B. I still label this as D, but this is P. Okay, so I want to find out this perpendicular distance. Okay, so according to this method, right? Okay, so first step number 1, you need to find out the unit vector of AB. So what is the unit vector of AB? Okay, so you have A, you have B. So AB is the direction of the line, right? Okay, so AB is equals to 2, 1, and 3. Right. Also, the modulus of AB is equals to 2 square plus 1 square plus 3 square. So I think the modulus of AB should be equals to square root 14. So that's my step number 1. Oh, I need to find out the unit vector first, right? So the unit vector for AB, you need to take the square root 14 divided by 213. All right, so eventually what do you have here? You should have 2 over square root 14, 1 over square root 14, and then 3 over square root 14. Okay, but for me, right, I feel that it is very troublesome. So maybe I will just keep it like this. You can just put it like 213 divided by square root 14. Or maybe you can put it like this. 1 over square root 14, then 213. So this is the unit vector of AB. Alright, then next you need to find out the modulus of AC and also the modulus of AB. So AC means AP in our example here. Okay, so AC means AP in our example here. Alright, so you can continue. Maybe I can write second step here. Wait. Okay, so this is my second step. Alright, so my second step is I want to find out okay. AC. Do I need to find AC now? I need to find out AD now. Okay, wait. according to the notes, right, the second step is find AC and AD. Okay, so maybe for me, I need to find AC first. Yes, correct. So AC first. AC means AP in this example. Right, so to find AP, you have the passing point, right, which is this one, 1, 3, and -4. So you have -1, -3, and also 4, plus OP. So what is your OP? -1, 4, and then 11. Okay, so this is your AC, which is AP in our example here lah. So you should have -2, 1, and 15. All right, so this is my AC. Okay, then next one, what you need to find? You need to find out the modulus of AC. Okay, so the modulus of AC, you should have -2 square plus 1 square plus 15 square. Yeah, all right, so what is the answer that you get? I don't know. I didn't try to find out the final answer here, so it is a value here. Okay, I put it as a square. All right, so this is the modulus of AC. Then after that, you need to find out the modulus of AD. Okay, so how to find out the modulus of AD in our notes? Okay, so modulus of AD, at first, you need to find out AC dot AB first. So AC means AP in our syllabus, in our example here, dot the unit vector of AB. Okay, so what is AC? So AC is -2, 1, 15 dot 213 divided by square root 14. I just want to let you know that this is the unit vector of AB. Okay, all right, so this is the unit vector of AB. So once you substitute and you try to simplify, you should get 42 over square root 14. All right, so this is actually the value already lah, the value for AD. Okay, the modulus. So if you continue from here, we go to the last step. So for the last step is you are trying to apply the formula PD is equals to square root AP square minus AD square. Okay, so which is equals to square root the answer that you get just now. Here, you square it and then you minus 42 over square root 14 square and then you take square root. So you should be able to get the answer which is square root 104. Okay, so you can try to figure it out on your own. But for me myself, I seldom use all this. So you'll see that I'm not so familiar with the process and steps. But if let's say you found, hey, this is quite easy for you to understand and you understand quite well with this method, then you can sure apply it in the exam. All right, so if you want to practice, you can practice this method on example 21 also and double check and see whether you really understand or not. If you don't want, then you can just stick to one particular method that you like the most. All right, so here we end our chapter 8 vector chapter already. All right, so you can start doing the partial question. All right, but I will create another video to discuss about the partial question that you should try out. There are some questions that you cannot try, but I will create another video to explain on this. All right, so I will see you in the next video.